Now there are certain properties of the vector product. So vector product has certain properties. The vector product is not commutative. For example, if we take cross product of A and B, it will not be equal to cross product of B and A. However, the cross product of A and B will be equal to the cross product of negative of B and A. So this is shown in the following statement that vector cross product of A and B is not equal to cross product of B and A. Rather, cross product of A and B will be equal to negative of the cross product of B and A. Now, the vector product is distributive. Now, what exactly we mean by distributive? Suppose that we take a number 2, it is multiplied by 3 plus 5. So, it is 2 into 3 plus 2 into 5. The same concept is used in the vector product is distributed. So, we are finding vector A multiplied by addition of vectors B and C, and that can be written as the cross product of A and B, adding to it the cross product of A and C. Now, in the next concept, the magnitude of the vector. When we use the term magnitude, we consider a vector and we take the modulus of that vector, and that is called the magnitude of vector. So, magnitude of the vector product of two vectors mutually at right angles is equal to the product of magnitudes of the vectors. When we use this term magnitude of the vectors, we have to take the modulus of those vectors. Now it is shown here that cross product of A and B equal to AB. Now it is the scalar term multiplied by sine 90 into unit vector. So AB into unit vector is equal to modulus of the cross product of A and B, and that is found to be AB. If theta is 90, that is sine 90 will be 1 in that case. Now in another concept, the vector product of the two parallel vectors is a null vector, that is 0 vector. And cross product of A and B will be equal to AB into sine 0 into unit vector. Sine 0 is 0, so the net result of the cross product of AB, that will be 0. The vector product of the vector by itself is a null vector, that is the 0 vector. So we are finding here that is the cross product of A and B. So we are multiplying vector A with vector A. So the lines will be parallel, angle will be 0, so sine 0 into unit vector. That is equal to 0 because sine 0 is 0. Now we come towards another property. The vector product of the unit orthogonal vectors are I, J and K. That is unit vectors along x-axis, the y-axis and z-axis have the following relations in the right-handed coordinate system. So we find I, J and K. So these are the three unit vectors, and according to this, the cross product of I and J will be vector K. The cross product of J and I, if their places will be interchanged, it will be negative of unit vector K. So we will remember I, J and K are along x-axis, the y-axis and z-axis. So if we take the cross product of J and I, it will be vector of minus K. Now we take the cross product of J and K, that will be vector I. But if we change the placement order, it will be vector K. That is the cross product of K and J, that will become minus vector I. The cross product of K and I will be J, but the cross product of I and K will be minus J. So if we change the place or the order, or if we change the place of the unit vectors, the other vectors will become negative. Now, the cross product of unit vectors, that will be 0. Similarly for cross product of J, similarly cross product of K. Now, the magnitude of each of the vectors I, J and K will be 1. and the angle between any two of them will be 90, and sine 90 is always 1. Therefore, we write cross product of I and j as 1, and 1 into sine 90, that is unit vector, n, where unit vector is a unit vector perpendicular to the plane of I and j, that it is just a third unit vector k. Now, the vector product of two vectors in terms of their x, y, and z components. So now we take the vectors along x-axis, the y-axis, and z-axis. So they are expressed in the form of a determinant, that is the rows and columns. So now there are two vectors, a and b, and let us write their rectangular components in the form of determinants. So first of all, we have written a and b. A is written as the vector a along x-axis multiplied by unit vector along x-axis. So then we write ay into unit vector along y-axis. Then az into unit vector along z-axis. And the similar interpretation for b. These are the two vectors given. Now we have to take the cross product of a and b. That is axi, ayj, azk multiplied by bxi plus byj plus bzk. If we directly multiply axi with bxi, then axi with byj, then axi with bzk, then similarly we have to multiply ayj with the three numbers. In all, the cross product of a and b will be of 9 numbers. So before that, instead of doing that, we take the calculations in the form of determinants. So we have multiplied actually, and we have written in the form of determinants. So the vector product of a and b, we have made one column of unit vector I, unit vector j, unit vector k, and we have written ax, ay, az, bx, by, bz. We have taken basically the coefficient of bz, we have taken the coefficient of ax, and that is the cross product of a and b. Now we come to certain example. The vector from origin to point a and b are. So now two vectors are given. Their values are 3i, 6j, 2k, and 2i plus j minus 2k. Find the area of the triangle OAB, the parallelogram formed by OA and OB as adjacent sides. Now we have taken the determinants. That is, OA is known to us, that is A. OB is also known to us, that is B. Then we have taken cross product of A and B. So in the one column, we have written I, J, and K. Now, for A, we have taken the coefficient of I, that is 3, the coefficient of j, that is minus 6, the coefficient of k, that is 2. Then in the next column we have taken, that is coefficient of I, that is 2, coefficient of j, that is 1, coefficient of k, that is minus 2. And we have simplified according to the calculations of determinant, that is minus 6 and minus 2. They are multiplied together, and that is 12. And then we have subtracted 2 from that. That is, I will be 2. The same principle we have adopted for all the columns and rows. And the net result after the calculation comes to be 5 root 17. Now, area of triangle is half base into altitude. So that we have computed here, and the value comes to be 5 root 17 by 2 square units. Now, the area of parallelogram, that is given as OA and OB is adjacent sides. So it is given as the modulus of cross product of A and B, and that is 5 root 17 square units. Now another example, there are two vectors given. So first it is written cross product of B and A, and then it is written cross product of B and A. That is, we have to find cross product of BA and cross product of BA if vector A is given and vector B is given in the two parts. Now, in the first part, the cross product of A and B is calculated with the help of determinants. So, one of the column will be I, J, and K. Now if you check vector A, then the coefficient of I is not existing, so we have written 0. But for J, the coefficient is 4, and for K, the coefficient is 3. But if we check B, then coefficient of I is 1, that of J is 1, and that of K is, that is minus 3. So in all, the value comes to be minus 7I plus 3J minus 4K. Now we come to the second part. The earlier part was cross product of A and B. The now part is cross product of B and A. The similar type of calculations we have made. The signs have been changed. 7I became positive and 3J negative and 4K will be positive. So cross product of A and B, again the determinants are applied and we got the values minus 3I plus 5J plus 11K. So cross product of B and A, again with the help of determinant, we will find that the signs will change. Earlier it was minus 3I and now it is plus 3I. Earlier it was 5J, now it is minus 5J. Earlier it was plus 11K and now it is minus 11K.